I just wanted to go over some problems with you from your homework, 3.4 trig equations. This pertains to the technology identities problem. Okay, this is question 1 from your 3.4 trig equation technology identities homework. To use an identity to solve the following equation on the interval 0 to 2 pi. So we know we have to be in radians because it tells us that we're in the interval 0 to 2 pi. So we have 2 sine squared x plus cosine x minus 1. We can't solve this because it's in both sine and cosine, so we need to make it in terms of either just the cosine or just the sine. The way we can do that is to use the Pythagorean identity, and the Pythagorean identity is sine squared x plus cosine squared x is equal to 1. Since I have a sine squared x, I'm going to isolate this sine squared x by subtracting the cosine squared x on both sides. And what that does is it sets sine squared of x is equal to 1 minus cosine squared of x. So now we can substitute the sine squared of x with 2 times 1 minus cosine squared of x. So we're substituting sine squared x with 1 minus cosine squared of x plus cosine of x minus 1 equals 0. Let's distribute the 2. So 2 times 1 is 2. 2 times, we have 2 minus 2 cosine squared of x plus cosine of x minus 1. Combining like terms, so 2 minus 1, we have negative 2 cosine squared of x plus cosine of x plus 1 equals 0. Now, this is now, it's in quadratic form, and how we solve this is to factor, but it makes it difficult to factor if your leading coefficient is a negative. So I'm actually, either you can add this to the other side, or we can just multiply everything, both sides, by -1. Multiplying this by -1, this -1. And that gives us positive 2 cosine squared of x minus cosine of x minus 1 equals 0. Now we factor. I'm going to replace the cosine of x with a's just to make it easier to factor. And so we can think of this as 2a squared minus a minus 1 equals 0. Now going to back to your algebra, where how do we factor this when the leading coefficient is something other than 1, is you multiply the leading coefficient with your constant term, the a times the c. So 2 times -1 is -2. And I use a Bayes method to find a product of -2 that adds to the b term, the -1. And two numbers that do that are -2 and +1, because -2 times 1 is -2, and -2 plus 1 is -1. Now we write this into a 4-term expression, so 2a squared. The -1a, we're going to rewrite that as -2a plus 1a minus 1 equals 0. We factor by grouping, by looking at what can we factor out from 2a squared and 2a. You can factor out a 2a from both. 1a and 1, you can only factor out a 1. So if we factor a 2a from 2a squared, we get a. 2a divided by 2a is 1. Here we factor it out a 1, we get a minus 1 equals 0. So we put a minus 1 in one factor, the 2a plus 1 in the other factor. So now we solve for a. This is going to be a is equal to -1/2, and a is equal to 1. Remember what a is. A, we set it as cosine x. So I have to now rewrite this a as cosine of x is equal to -1/2. And that cosine of x is equal to 1. For this, you're going to use your unit circle. You're looking at where the unit circle is equal to where the x values, right? This is the x values are -1/2. Well, on the unit circle, the x values are -1/2 at radians, the angle 2 pi/3 and 4 pi/3. And where's the x value, +1 at angle 0 radians. So there's 3 solutions. We have 0, 2 pi over 3, and 4 pi over 3. Okay, let's look at another problem together. We have, this is question 3. 9 minus 9 sine theta equals 6 cosine squared theta. Again, you have a sine and a cosine squared. So we're going to use the Pythagorean identity, sine squared plus cosine squared theta is equal to 1. I see I can replace the cosine squared theta, so we're going to subtract sine squared theta on both sides. And that gives us cosine squared theta is equal to 1 minus 2 sine squared theta. So let's substitute cosine squared theta. That's going to be substituted with 1 minus 2 sine squared theta. I'm sorry, not 2, just 1 minus, I don't know where I got the 2 from. 1 minus sine squared theta. And then on this side, we have 9 minus 9 sine theta. Let's distribute. We have 9 minus 9 sine theta equals 6 minus 6 sine squared theta. Now I'm going to get all the terms on one side. I'm going to, by adding 6 sine squared theta on both sides, I'm going to also subtract the 6. Actually, let me do this. Subtract the 6 from the 9, I'll add 6 sine squared theta. Okay, so the 6 and these on the right-hand side, we have 0. On the left-hand side, we have 6 sine squared theta minus 9 sine theta plus 3. We can factor out a 3 from 6, 9, and 3. So 3 factored out gives us 2 sine squared theta minus 3 sine theta plus 1 equals 0. Now I'm going to substitute A in for sine. And so A, I'm going to set that to sine theta. And so if I rewrite this, you get just the parentheses, you get 2a squared minus 3a plus 1. Why do we do that? If you can factor this out with just the sine theta, that's fine. Just trying to make it easier for you guys to factor this. So we multiply the last and the first, and then we get 2 times 1, which is 2. We find out what product then adds -3. It's going to be -2 and -1. Because -2 times -1 is +2. -2 minus 1 is -3. So we split -3a as -2a minus 1a, bring the 2a squared down, and bring the 1 down, equals 0. What can we factor out from 2a squared and 2a? They both have a common factor of 2a. From -1, a and 1, they have -1. When the middle, that sign is a negative, you have to factor out a negative. So factoring out 2a leaves us with a minus 1. Factoring out -1 from -1a plus 1 is +a minus 1. And then put the 2a minus 1 together, and then the a minus 1. We solve for a here, we get a is 1/2, and a is equal to 1. Remember though, sine theta is a, so we need to reset that up. As sine theta is 1/2, and sine theta is 1. Now for the unit circle. The unit circle, you're looking at where's the y-coordinate equal to 1/2 on the unit circle. And where that happens, where the y-coordinate is 1/2, is pi over 6 and 5 pi over 6. And again, sine theta is equal to 1, so you're looking at where's the y-coordinate 1 on the unit circle, and that's going to be at pi over 2. Okay, so the solution is pi over 6, 5 pi over 6, and pi over 2. Okay, let's look at another one. Here's number 5. And while this problem looks simple, I find that students find these problems one of the challenging ones under trig equations. So we have sine x is equal to 0.9066. and we need to find the equation in the interval. So we're in radians, 0 to 2 pi. So remember, sine represents the y coordinate. So if you think about this is a positive y value, where is the y value positive? Well, the y value is positive in quadrants 1 and quadrants 2, because remember here, the y value is 9.6, not 0.9066, and here we're saying at which angle is it, does the angle give you a y value of 0.9066? So there's two angles that we're looking for, angle 1, and then here, angle 2. So to find angle 1, what we do is we take the inverse sine of 0.9066, and you can use your graphing calculators for that, and make sure that you are in radian mode. So go to mode here, make sure you're in radian mode, and then we quit out and you do inverse sine of 0.9066. It gives us 1.13. We're going to round to 4 decimal places, 1.1352. So I'm going to write that. It's 1.1352 radians. Okay, so that's this angle, the first angle here. This angle right here is 1.1352. Okay, so I know the reference angle, this one, is also 1.1352. But we want to know from 0 to that terminal side. And so what we can do is we want to take this angle out by subtracting it from pi, because halfway around the circle is pi. So if we take that little bit off, that'll give us the equivalent angle. So we do that angle 2 is pi minus 1.1352. And I won't show you that in the calculator, I'll just type it here. So if we do that, that'll give us around to 4 decimal places, 2.0064 radians. So the solution for this is 1.1352 and 2.0064. How you can double check whether this is really the values that give you 0.9066 is you can put that in the calculator and to double check. You can do sine of 1.1352. It should give you something close, right? 0.9066. And we do the same thing, sine of 2.0064. And that also give you 0.9066. Okay, let's try another problem. Question 7 in the same homework set. We have tangent this time of x equals -10. Tangent is a little hard to work with because remember, tangent represents the ratio y over x. So -10 represents when y is divided by x is equal to -10. So think about where tangent is negative. Tangent, or y divided by x, is negative when they're opposite signs. And they're opposite signs in quadrant 2 and quadrant 4. And so what we need to do is first, we're going to find the first angle, and the inverse tangent function is going to give us a negative angle there for the first angle there. And then we also need to find this angle right here. That's going to be the second angle. Okay, so let's take the inverse of -10. That'll give us the first angle. Okay, so if we take inverse of tangent of -10, it's going to be -1.4711. And so if I'll write this as negative 1.4711, but we don't want negative angles because it has to be in 0 to 2 pi. So what we need to do is, because this is a negative angle, we can add 2 pi, right? We can find coterminal angles by adding 2 pi to it. And that'll give us this angle right here if we add 2 pi. And so let's add 2 pi to this. We add 2 pi. So I'll add plus 2 pi. That'll give us 4.8121 if we round that 5 to a 1. 4.1821. 4.8121, I'm sorry. Okay, so that's our first angle. And oops, I meant to find angle theta is versus 4.8121. And now we need to find the second angle. Well, the reference angle here is going to be 1.4711. But because I need to find the reference angle from 0, the x-axis, the initial side being the angle starting from the positive 0 x-axis and going to the terminal side, what we need to do is subtract pi, because remember the halfway is pi. So the second angle, writing Q's, second angle is pi minus 1.4711. And if we do that, that'll give us 1.6705. Okay, so your solution is 1.6705. 4.8121. Okay, how do you check? Again, you can plug into the calculator by typing in, okay, tangent of 1.6705 should give you close to negative 10 because we rounded, it's not exact. And then you can do tangent of 4.8121. That'll give you something close to negative 10. Okay, let's look at another one. This is 2 cosine x minus 1 equals negative 0.8084. This time we have to be in degree mode because it says solutions must be from 0 degrees to 360 degrees. So just watch out for that. And so let's solve for cosine x, and we can do that by 2 cosine of x minus 1 equaling negative 0.8084. We can add 1 to both sides, and that'll be 2 cosine of x is equal to, putting it in my calculator gives me 0.1916. Then we'll divide both sides by 2. We get cosine of x is equal to 0.0958. Okay, so this time cosine is positive, and cosine represents your x-coordinate. Where's the x-coordinate positive? It's positive in quadrant 1 and 4. So we're looking for 2 angles, one there, and then the other one is going to be, the terminal side is there, and it's going to be counterclockwise because we want positive angles. Okay, so let's take the inverse of 0.0958 and plug that in to the calculator. If we do that, first make sure that you are in degree mode. So let's make sure we change it to degree mode and type in inverse cosine of, what was it again? 0.095, oops, inverse cosine of 0.0958. Okay, that gives us 84 degrees. So our first angle here is 84 point, we'll round to 2 decimal places, 0.50 degrees. So then I know this reference angle is 84.50 degrees. So if I want, or negative, right, because we're going words. But if we just think about it as what the angle is, it's 84.50. But we want to go all the way around. So if we add negative, let me write this here. For the second angle, this is the first angle. For the second angle, if we add negative 84.50 plus 360 degrees, that'll give us angle 2. And if we do that, that's 275.50 degrees. So 2 angles in degrees is 84.50 and 275.50. Okay, I hope you found this mini homework problem review session helpful. Again, if you have any questions, please feel free to email us.